So the next task with dealing with discrete distributions is to look at how to find the mean and standard deviation for it. Right now, with the sigma squared, we're looking at the variance formula, but it easily fixed. To find standard deviation, just take the square root. So let's take a second and just look at what the formula is saying. To find the mean of a discrete distribution, I need to multiply each observation times its probability, and then take each of those numbers and add them up. And then whatever I get as a result is the expected value of that particular situation. To find the standard deviation, I need to take each observation minus the overall mean of the observations, square them, and then times the squared number times the probability of that particular observation, and then add it together. And the sum of those statements will give us the variance of the distribution. I can say it. In which case we take the square root to find the standard deviation of that. Okay, so let me give us a problem that we will look at here. Going back to the classes situation we looked at in an earlier problem, question is what would the average class load look like? What would we expect to see for a typical student at this college given these probability distributions here? Okay, so we are going to go to our stat list and input in these various numbers. Okay, so I want 1, 2, 3, 4, 5, 6, 7, and then I'm going to go over to list 2 and type that in. Okay, so from here, to find the mean, we're going to go in. The formula says to take the observation times its probability. So for our calculator, I want to take list 1 times list 2. So I'm going to arrow over to list 3. I'm going to go on top, and then I'm going to tell the calculator to take everything in list 1, multiply it by everything in list 2. And that'll give us a number. Okay. And then according to the summation symbol, I want to go in and add all of list 3 in. So let me go back to the home screen. And then let's go to where we have our sum located. And then I want sum of list 3. And so the mean of that of the mean class load is somewhere about 4.6 classes, which kind of makes sense. You've got 4's got 25% and 5's got 40%, so it makes sense that closer to 5 you'd expect a typical student to have that class load. And to find the standard deviation, we're going to go back to stat list. And actually, I misspoke here. We're going to go back to the home screen. I want to tell the calculator to remember this number, so I'm going to hit store and then alpha A, and then it's just going to remember that the mean happens to be 4.66. Then I'm going to go back to our stat list, and on top of list 4, so kind of now we got to keep track of what these things represent. Actually, I don't need list 3 anymore. Now what I need is I need a list of the observation minus the mean. So I need list 1 minus that mean that we just found, which was A. So list 1 minus A, and then hit enter. And then from here I need to square all of that. So I just need to square list 3. So list 3 squared gives us all of those numbers. And then let's see. So now we have observation minus the mean squared. So the next part says to multiply it by its probability. And which list was the probability in? That'd be in list 2. So at this point I need list 4 times list 2. Okay. It gives me all of those little tiny numbers there. And according to the formula, I just need to add up those observations. So go back to the home screen. And, sorry, one more time, I'm going to go back. So we are adding up list 5. Just make sure we all are aware of which list are we adding. We're going to go back and sum, go to list and then track down the sum function. And we want to sum list 5. And that would tell us the standard deviation is 1.44. Okay, now I'm about to show you the, I hate to say shortcut, but that's just what it is. I mean, we did it the long way. We actually did what the formula said. So there is a way to get the calculator to give us the mean and standard deviation of our distribution. If we go back to one var, actually let me go back to the list screen so we can stare at which list we want to do this on. So way back ago, list 1 represented our observations. List 2 represented the frequencies, how often these observations showed up. Everything else is just based on formulas that we're doing. So I want the mean of this distribution, so that's a 1 var statistics analysis. So I want to calculate 1 var stats. Again, this is should be a new thing for us. List 1 is where I have the main observations, but I want to tell the calculator this is how often these things show up. And so that we get from list 2. And then I want to hit calculate. And as it does all that for us, we should see, let's see, 4.66 is our mean, and that matches what we had. Now notice we have a standard deviation of 1.2, but we don't have a sample standard deviation, and that happens to be different than what we have. So we need to kind of talk about a little theory for a second. Okay, so just want to remind ourselves then of what happened here. We didn't get it wrong. It's this number, the 1.44 we calculated, that's actually the variance of the discrete distribution. The calculator gave us 1.2 as the standard deviation. So to go from standard deviation to variance, I just need to square it. So I just need to square 1.2. So I can go back to the home screen and just do 1.2 squared. And that'll give us the 1.44 that we had earlier. So that's how you find the standard deviation and mean using frequencies in the calculator. Okay, so the last question that we'll kind of investigate in this video today is what do we mean by the fair? Is a game fair? Okay, so it depends on who you ask. Not really. There is a mathematical definition of fairness, but I think a lot of people, when they go play games, like go to Vegas and they gamble, they think fair means they win money, and that's not actually what fair means. In a gaming sense, fair means if you sit down and play the game an infinite number of times and you count how many wins and losses you have, you'd expect it to be even. You'd expect to win as much as you lose and essentially walk away with nothing. Okay, so we're going to set up a probability distribution over this scenario that they're describing for us, and then we'll calculate the mean on it and see whether or not we think this game is fair. So let me get that set up. Okay, so let's talk about what things could happen. Finding out the probability is going to be another story, but when they roll the die, if they get a 2, there's a cost associated with that, right? So if they get a 2 or a 12, they win $20, but keep in mind they spent 3 to play the game. So how much did they really gain? They really gained $17. Okay, so that's one of our scenarios is 17. Sorry, I just bolded that for reasons I cannot tell you. All right, so let me add another column here. Okay, so if he gets a 7, he wins $5. Okay, but he spent 3 to play the game, so he really gained $2 on that. And the other option is that he doesn't win anything. He just gets zero for playing. I'm sorry, not zero. He wins $0, but again, it cost him $3 to play. So those are the three options as far as this game is concerned. And now the question is, what about those probabilities? Okay, so we have to kind of think about when we're looking at dice, how often can these various combinations come up? So how many different ways, when you're looking at dice, could you even get a 2 or a 12? Well, there's the only one way to get a 2 is if you get a 1 or a 1. And the only way to get a 12 is if you get a 6 or a 6. Okay. Now, at this point, we should have done a dice experiment. And so there would be 36 possibilities that could show up. So 2 out of these 36 will win the guy $17. Okay. Now, for the 7. So you got to think, what are the different ways we can get a 7? Well, there's 1 and 6. All right, so 1 out of 6 or 6 out of 1 is an option. 2 out of 5 or 5 out of 2. Okay, and then we got 3 out of 4 or 4 out of 3 is another option. And at that point, we think we've got them all. There's no other way to get a 7. And so that would be 6 out of the 36 possibilities. Okay, and so of the 36 ways that when we roll these two dice that this could happen, we've already accounted for 8 of them. So that means 36 minus 8 is 28. So 28 out of the other 36 possibilities, you end up getting nothing, right? Okay, so then what we can do, we could go straight to the calculator, but all they're really asking for is standard deviation. I'm sorry, mean here. What do we expect to win out of this? So we can actually just set this up by hand and then go type it in a calculator. And let me show you what I'm talking about here. Okay, so what I'm trying to say is we could do 17 times 2 out of 36 and add that to 2 times 6 out of 36. Let me try that again. 6 out of 36. And then negative 3 times the 28 out of 36. And so that we can go to the calculator and type that in. It's not that bad. Well, there's just a few numbers. It's not that terrible to type in. Okay, so when you type that in a calculator, you get negative 1.05. So what that means then is as more people play the game, if you keep giving out money in this fashion, each person that plays the game essentially expects to lose $1 every time they play. So the guy running this game is going to make money off of you. He just has to keep people playing. And that's kind of what Vegas does when they try to entice you with, you could win, but most people are going to lose. But the few people that do win, man, do they advertise that out. Anyways, so that's how you find whether or not so the answer is this game is not fair. That's what the answer is. So there you go.